We look up at the night sky, and we see stillness. We see a quiet velvet blackness, punctuated by the gentle, twinkling light of distant stars. It appears serene, a peaceful canvas stretched across eternity. But this is an illusion. The silence of space is not one of peace, but of immense, unimaginable distance. Across that void, events of such catastrophic violence are unfolding that they would defy our comprehension. The universe is not quiet, it is screaming. We are just too far away to hear it. This cosmic ocean, which seems so placid from our little shore, is filled with monsters. These are not creatures of myth, but of physics. They are forces of nature so extreme, so powerful, that they challenge the very laws that govern our existence. The darkness between the stars hides secrets. It is a realm where the rules we know break down completely. We send our probes, our telescopes, our ambitions out into this great unknown. We search for life, for understanding, for a reflection of ourselves. But what we are increasingly finding is a universe that is profoundly hostile. First, we must confront the ultimate abyss, the black hole. Nothing in the universe inspires such primal fear. It is the end of a story. When a truly massive star exhausts its fuel, it can no longer support its own weight. Its core collapses under immense gravity, crushing down into a point of infinite density, a singularity. That point tears space-time, creating a gravitational well so deep nothing can escape. Not just a dark object, the absence of everything, a point of no return, a one-way trip to oblivion. Around the singularity lies the event horizon, the edge of the abyss. To an outside observer, it looks like a perfect black sphere against stars. The last place light can orbit before being pulled in. If you cross that invisible line in a spaceship, you might not feel anything at first, but your fate would be sealed. You could never turn back. Space itself flows inward faster than light, carrying you to your doom. As you fall, gravity's power grows. The pull on your feet would be far stronger than on your head, stretching you. This grim process is called spaghettification. It would pull you apart atom by atom, turning you into a thin stream of plasma spiraling into the singularity. Time itself warps. For you, it might feel like moments. For distant observers, your fall slows, stretching into eternity, frozen and redshifted at the horizon. From the silent darkness of a black hole, we turn to the universe's most violent and luminous explosions, gamma-ray bursts, or GRBs. Imagine the entire energy our sun will produce in its 10 billion-year lifetime. Now imagine all of that energy released in just a few seconds. That is the power of a gamma-ray burst, the most powerful explosion since the Big Bang. For a brief moment, they can outshine entire galaxies. Focused beams of high-energy radiation racing at light speed. Cosmic death beams of unimaginable power. Two primary causes. Hypernova. A massive star collapses into a black hole and fires polar jets. Neutron star collision. Two ultra-dense remnants spiral together and merge. The merger sends a shockwave of gamma rays hurtling through space. If a beam were pointed at Earth from thousands of light years away, the consequences would be catastrophic. An extinction-level event. Gamma radiation strikes the upper atmosphere, ozone stripped in seconds. Without ozone, Earth is bathed in deadly ultraviolet radiation. Mass extinction devastates life on land and in the oceans. Nitric oxides form, creating chemical smog and acid rain that poison land and water. Life on Earth scoured from the surface. We would never see it coming, a flash in a distant galaxy. Then minutes or hours later, our biosphere unravels. Their sheer randomness is terrifying. We've detected GRBs in distant galaxies across the sky. The odds of one aimed at us are slim, but not zero. Some scientists think a past mass extinction may have been caused by a nearby GRB, a stark reminder of the cosmic lottery. We've been lucky so far. When a star more massive than our sun, but not quite massive enough to form a black hole dies, it also collapses. The collapse is so violent that it crushes protons and electrons together to form neutrons. What is left is a neutron star, one of the strangest and most extreme objects in the universe. Imagine taking a star 1.5 times the mass of our sun and crushing it down into a sphere just 20 kilometers across the size of a city. The result is, well, an object of almost unbelievable density. A single sugar cube-sized piece of a neutron star would weigh 100 million tons. Its gravity is second only to a black hole. These stellar corpses are far from dead. Many of them are born spinning incredibly fast, hundreds of times per second. As they spin, they emit powerful beams of radiation from their magnetic poles. If these beams happen to sweep across our line of sight here on Earth, We see them as regular pulses of energy. We call these objects pulsars. They are the universe's lighthouses, sweeping their beams across the cosmos with a regularity so precise they rival atomic clocks. They are the ticking clocks of dead stars, a constant rhythmic reminder of the violent stellar deaths that populate our galaxy with such strange and wonderful objects. But there is a more extreme, more terrifying variant, the magnetar. These are neutron stars with magnetic fields that are 1,000 trillion times stronger than Earth's. They are the most powerful magnets in the known universe. This magnetic field is so colossally powerful that it can buckle the star's surface, causing a starquake. These events release vast amounts of energy in the form of X-rays and gamma rays. Our planet orbits a stable star, nestled in a solar system that has been our home for billions of years. But not every planet is so lucky. Out in the cold, dark void between the stars, there are wanderers. These are rogue planets, worlds ejected from their home systems, drifting alone through the galaxy. They are cosmic orphans, doomed to an eternity of darkness and cold. Our galaxy could be teeming with them, perhaps billions or even trillions, silently gliding through the interstellar medium, unlit by any star. They are ghosts in the cosmic graveyard. These planets are incredibly difficult to detect. Without a parent star to illuminate them, they are almost completely invisible. We can only find them through gravitational microlensing, where a rogue planet passes in front of a distant star and its gravity briefly magnifies the star's light. Each detection is a fleeting glimpse of a world lost in the dark. These planets could be anything, small, rocky bodies, or massive gas giants larger than Jupiter. Thrown out by gravitational interactions early on, they travel a lonely, endless journey through the Milky Way. Life seems impossible on such worlds. Without a sun, the surface would be frozen solid, just a few degrees above absolute zero. The sky would be a constant star-filled black with no dawn. And yet some scientists speculate life could find a way. A large rogue planet with a thick hydrogen atmosphere could trap internal heat. Or a rocky world with a subsurface ocean like Europa could stay liquid from tidal forces or from radioactive decay in its core. We often think of the dangers of space as being far away, in the distant corners of the galaxy. But one of the greatest threats to our civilization lies right on our doorstep. It is our own sun. Our star is a source of life, light, and warmth. But it is also a volatile, magnetic beast. It can unleash powerful eruptions known as solar flares and coronal mass ejections. Usually these are minor events, creating beautiful auroras. But our sun is capable of something far more violent, a superflare. A superflare could be hundreds of times more powerful, or even thousands of times more powerful. Evidence for these events comes from studying other stars similar to our sun. We have seen them unleash flares of unimaginable magnitude. By studying tree rings, we have also found evidence that Earth has been hit by smaller but still significant solar storms in the past. The Carrington event of 1859 was one such storm. It was powerful enough to set telegraph offices on fire and create auroras so bright that people could read newspapers by their light at night. Today, a storm of that magnitude would be devastating. A true superflare would be orders of magnitude worse. It could send our modern technological civilization back to the Dark Ages. If a superflare were to strike Earth, it would first overwhelm our planet's magnetic field. A wave of high-energy particles would wash over the globe. This would induce massive electrical currents in our power grids, causing transformers to overheat and explode on a continental scale. The entire grid could collapse in a matter of minutes. Satellites in orbit would be fried. They control our communications, navigation, and financial systems. It is a place of extremes, where creation and destruction are locked in a constant, brutal dance. The same forces that forged the galaxies and ignited the stars also create phenomena of pure terror. These are not hypothetical boogeymen. They are real, observable, and utterly indifferent to our existence. They are the true titans of the cosmos, and we are but fleeting specks in their vast domain. Imagine a weapon that could sterilize a galaxy. Imagine a gravitational pull so strong that not even light can escape its grasp. Imagine an object so dense that a single spoonful would weigh more than all of humanity combined. These are not flights of fancy. They are the everyday reality of the deep cosmos. The universe is a grand and beautiful tapestry, woven with threads of light and life. But it is also a place of shadows, a place where the fabric of space-time itself can be torn asunder. As we peer deeper into the darkness, we are forced to confront a humbling truth. Our planet, our home, is a fragile sanctuary in an incredibly violent neighborhood. And so, we begin a journey into that darkness. We will step away from the comforting glow of our own sun and venture into the haunted depths of space. We will confront the universe not as a gentle mother, but as a place of raw, untamed power. We will look into the abyss, and we will see the wonders and the terrors that lurk there, waiting in the silence. This is a tour of the most extreme, most dangerous, and most awe-inspiring phenomena known to science. It is a reminder that in this vast, silent universe, there are things far more frightening than the dark. The true monsters are the ones made of physics and light. We've been lucky so far. We have not been in the firing line. In the blink of an eye, everything we know could be erased by a flash from across the void. A starquake on a magnetar just 50,000 light-years away in 2004 was so powerful that it measurably compressed Earth's ionosphere. It was a burst of energy from across the galaxy that had a physical effect on our own planet. The environment around a magnetar would be a realm of pure hell. The magnetic field is strong enough to distort the electron clouds of atoms, rendering chemistry as we know it impossible. It would strip the data from your credit cards from 100,000 kilometers away. Get any closer, and the magnetic field would rip you apart on an atomic level as the iron in your blood was violently torn from your body. Neutron stars, in all their forms, are fascinating. They are stellar zombies, the crushed remains of once mighty suns. They are a testament to the fact that even in death, a star can be more powerful and more bizarre than we can possibly imagine. We have journeyed through the darkness from the inescapable gravity of black holes to the lonely wanderings of rogue worlds. We have witnessed the universe's most violent explosions and the awesome power of its magnetic behemoths. We have even seen the danger that lurks in the heart of our own solar system. It is easy to look upon these phenomena with fear. The cosmos is a place of extremes, forces so vast and powerful that they make our own existence seem impossibly fragile. The universe is, without a doubt, a terrifying place. It is a realm of fire and ice, of silent voids and cataclysmic collisions. But to see only the terror is to miss the other half of the story. For in this violence, there is also a profound and staggering beauty. The death of a star in a supernova, a violent and destructive event, is also what forges the heavy elements, carbon-oxygen ion that are necessary for life. The swirling accretion disk around a black hole, a place of no return, glows with a brilliance that can outshine a billion suns. The intricate patterns of a nebula are the scars of ancient stellar battles, but they are also the nurseries for new stars and new planets, new possibilities for life. Our fear of these cosmic monsters is rooted in our perspective. We are small, fragile beings tied to a single delicate planet. From our vantage point, the universe is dangerous. But from the perspective of the cosmos itself, these events are not monsters. They are simply part of a cycle. They are the engines of cosmic change, the mechanisms of creation and renewal. The universe is not for us. It does not care about our survival, it simply is. And its laws, which can create such terror, are the very same laws that allowed for our existence in the first place. And so, we are left with a sense of profound awe. We live in a universe that is both terrifying and beautiful, destructive and creative. It is a place of deep mystery, and with every new discovery, we find that it is stranger and more wonderful than we ever imagined. The silent scream of the cosmos is not just a cry of violence, it is also a song of creation. Our existence is a brief, flickering candle in an immense and powerful darkness, and our purpose perhaps is simply to be here to witness it, to appreciate the terrible, magnificent beauty of it all, before our light too is extinguished.